Welcome, dear my students. So this is the last unit, that is the fifth unit from your syllabus, and that is the contain two chapters. In that first chapter from the fifth unit is carboxylic acid. So let us we start with our first chapter, carboxylic acid. Already we know about the scope of the syllabus, that is this subject deals with the classification and nomenclature of simple organic compounds, structural isomerism, intermediate forming in a reaction, important physical properties, reaction, and the method of preparation of these compounds. The syllabus also emphasizes on the mechanism and orientation of reaction. So all these are the scope related with the pharmaceutical organic chemistry first. There is another thing related with the scope is that upon completion of the course, the student shall be able to first of all write the structure, name, and the types of isomerism and the of the organic compound. Then write the reaction, name reaction, orientation of reaction, account for the reactivity, stability of the compound, identify, then confirm the identification of the compound. So these are the some of the scope we required after the completion of this course. Then course content. So from the fifth unit, there is a course content is general method of preparation and reaction of the compound, which is specifically astigmat, that is carboxylic acid with astigmat. So before going to know about different properties, we also know about some general methods of preparation of reaction of this carboxylic acid compound. Then to emphasize the definitions, types, classification, principle, mechanism, application, example of the different types of this carboxylic acid. Then main thing related with this course content of the carboxylic acid is acidity of the carboxylic acid, effect of the substituent on acidity, then inductive effect and qualitative test for the carboxylic acid, amides and esters. Then structure and the uses of acetic acid, lactic acid, then tartaric acid, citric acid, succinic acid, oxalic acid, salicylic acid, and so on. So lots of the compounds are there for the study of their structure and uses. Then let us consider the what it include on all these presentation. So it include introduction, structure, nomenclature, isomerism of carboxylic compound, along with method of preparation, physical properties, chemical properties concerned with these carboxylic acid compounds, and qualitative test for the identification of carboxylic acid, then structure and uses of various earlier described carboxylic acid compound. Then let us we move towards the introductory part of this carboxylic acid compound. So this class of compound, that is carboxylic acid compound, have the general formula, that is the R C double bond O OH, or it is also indicated by RCOOH or RCO2H. So accordingly we can represent the carboxylic acid as like this. Then there is a where an alkyl group R bonded to the COOH group. The functional group COOH is in fact made the carbonyl group joined to. So this is a carbonyl group, C double bond O, joined to the hydroxyl group or OH group. So it becomes carbonyl group plus hydroxyl group, and it will form the carboxylic group. So it represent for the aldehyde group, it represent the alcoholic group OH group, and represent of all this combination it called as a carboxylic acid group. Then next is it introductory part also contain illustration of this particular carboxylic acid. So the combination or the combined COOH is designated as carboxylic acid, which is a contraction of the carbonyl and hydroxyl. So carbonyl hydroxyl. So it is the combined group. So Although the carboxylic acid is virtually a union of one carbonyl and one hydroxyl group, the properties of these constituent functional groups are profoundly modified due to their mutual interaction. Means what is happen, they are not shows the specific property of the aldehyde ketone as well as the OH, because it is a combined with group forms a different properties. So thus the carbonic or a carboxylic group does not give the reaction shows by the aldehyde on ketone, and its OH group is definitely not alcoholic. So although it contain the carbonyl group or OH group or hydroxyl group, that doesn't show the basic properties of respectively aldehyde and ketone in this, because it is a different from all these two compounds. So carboxylic group taken a whole shows a characteristic property, and in it shows own regard as a independent functional group. So it is independent group, that is it is even if it is combination of both of carbonyl and OH group, but it is having the independent characteristic. Therefore the compound which contains the OH group are the acidic and are better considered as a separate class called as a carboxylic acid. So it is because of that it gives the independent functional properties, it is considered as a separate class as a carboxylic acid group containing compound. So they are further termed as a monocarboxylic acid and dicarboxylic acids, tricarboxylic acid, etc. according as number of COOH group present in molecules 1, 2, 3 and more. Then next, monocarboxylic acid. It is the first type of the carboxylic acid, in that they contain one carboxylic group attached to the hydrocarbon group. So it is only one carboxylic group attached, so because it is called as a monocarboxylic acid. They are called saturated acid or unsaturated according to the hydrocarbon group to which the COH group is bonded, and is saturated or unsaturated. So according to which what type of the hydrocarbon group it is attached, again divided into saturated or unsaturated monocarboxylic acid derivative respectively. So for example, propanoic acid saturated because it doesn't contain the hydrocarbon which is a double bond, so it is saturated. Here is a crotonic acid and acrylic acid is both of having the unsaturated hydrocarbon, so it is considered as unsaturated monocarboxylic acid or acids. So the saturated monocarboxylic acid are also commonly referred to as a fatty acid, saturated, since many of them are particularly the higher or members are obtained by the hydrolysis of a fat. So we'll get idea about this is the fatty acids, saturated fatty acids. Then electron, if you consider the structure of this particular carboxylic acid compound, so before we get we'll get idea about electron and neutron diffraction studies have revealed that the carboxylic group represent a planar arrangement of atom. So this is of a planar arrangement of atom. We'll see that is this shows that carboxylic compound carboxylic carbon and the two oxygen atom in carboxylic acid sp2 hybridized. So these are the sp2 hybridized carboxylic acid compound carbon. Then these three sp2 hybridized orbital of the carboxylic carbon overlap with the two sp2 orbitals of the two oxygen atom. So what is happen? These are the carboxylic acid carbon which having sp2 hybridized orbital which overlap with the two oxygen atom having a sp2 hybridized orbital. So this is sp2 hybridized orbital overlapping with CO and CO here of both carbon, both oxygen atom. Then the sp2 hybridized orbital to oxygen atom and the sp hybridized orbital of the alkyl group to form a 3 bond. So here is 3 bonds are formed here, that is single sigma bond, and on sp2 hybridized orbital, one of the 2 oxygen further overlap with s orbital of oxygen. So further sp orbital of the oxygen overlap with the s orbital of the hydrogen atom. According to that, OH. So it becomes C double bond O CO, and it is COOH here. So RCOCOH as like this. So we will get idea about the structural features, that is carbon atom having sp2 hybridized orbital overlap with the oxygen atom, which is also having sp2 hybridized orbital as that of C double bond O, and which forms sp2 hybridized orbital. Here is another carbonyl group of the carboxylic acid bonded to the another oxygen atom having the sp2 hybridized orbital. So it forms sp2 hybridized orbital, and remaining orbital of the oxygen bonded to the s orbital of the hydrogen form sp2s orbital structure here. So it will forms the structure, and another group, another sp2 hybridized sp3 hybridized orbital of the R group bonded to the sp3 orbital. So depending upon that specific type of the alkyl group attached to the carbonyl group gives the sp2 sp3 hybridization here. So the structure also having the specific characteristic, that is each of the 2 oxygen atom and the carboxylic carbon are now left with the 1p orbital perpendicular to the bonding skeleton. So all these are 3 unused orbital overlap, so that resulting the bond partly delocalized between carbon and 1 oxygen on the one hand and the carbon and the second oxygen of the other hand. So illustrated on all figure, that is specifically with this structure of orbital, and this delocalization explain the elegantly why, that is CO single bond is shorter. CO single bond is a shorter bond, that is 1.36 angstrom than the CO bond single bond of alcohol. Here CO bond, which is a 1.43 angstrom in alcohol and other. So C double bond O bond in a carboxylic acid is slightly longer, that is 1.23 K, and other normal C double bond O bonded with the specific 1.20 angstrom is ketone in aldehyde. So instead of that K, that is angstrom, please consider this, and we'll get a difference in the particular bond strength in each and alcohol, carboxylic acid, ketone. Due to that, it will give the different properties in that case.